Okay, how many ways can 10 people line up for a photo if Alice, Barbara, and Courtney must be together? So a similar question, except of course now we have 10 people and there's 3 that we're trying to keep together. So let's go through a slightly longer way and then of course focus on a more efficient way towards the end of this video. So I've already written this out, so you spare you from watching me copy all this down, but of course these are our 10 spaces corresponding to the lineup of 10 people, and I've been trying to keep track of how many ways we can keep A, B, and C, Alice, Barbara, and Courtney together. And you can see that I have 1, 2, 3, 4, 5, 6, 7, 8, at least as a starting point, 8 different ways. Now this gets a little bit trickier because of course we have to ask ourselves, well, how many ways can we cycle the 3 girls when they are together? So more specifically, if A, B, and C happen to be in those first 3 spaces, we can obviously rearrange. We could put Courtney on the far left or Barbara on the far left, etc. And hopefully you're saying to yourself that I think I know how many ways we can arrange 3 people. And of course that's going to be 3 factorial, or 6 ways. And we can quickly scribble those down. So for every one of these rows here, I should actually have 6 rows in total to correspond to the total number of ways we can keep Alice and Barbara and Courtney together. So A, B, C, and I'm just going to switch the order of B and C. And then I'm going to start with Barb. And then we'll go A, C, Barb again. Switch the last 2 letters, C, A. And then we have 2, of course, where Courtney's on the far left. And I'll go alphabetical order and reverse alphabetical order. And of course, that corresponds to 6 possible ways. So how many ways can we line up these people and keep these 3 girls together? And of course, it's going to be 1, 2, 3, 4, 5, 6, 7, 8. Did I count that correctly? 1, 2, 3, 4, 5, 6, 7, 8 times 6. So we'll say 8 times 6, and we need one other number, and that's of course what about all the other people that are standing around. And of course if there's 10 people, you can easily see here in this diagram that there's 7 people remaining, and of course that's our fundamental counting principle to fill in the rest of those spaces. 4, 3, 2, 1, or of course 7 factorial for short. So here is our answer. So we got 8 different scenarios, cycling the girls through, followed by filling up the rest of the slots with the remaining people. And we'll check this on our calculator right now, and then we'll have a quick look at our more efficient way of doing this question. So we have 8 times 6 times 7 factorial. And so of course no brackets needed here because we're not dividing anything. 8, 6, 7 factorial, so 241,920. We'll just say ways, possible photos. And checking my memory there. Okay, so what's the slightly more fit? Now, of course, if you understand this and it doesn't take you that long, that's not a bad way of doing the question, but let's try to be as efficient as possible. And if we realize we have 10 people, of course, the same information in the question, and we're trying to keep A, B, and C together. Remember, the trick is to treat those 3 people as one item. So we're going to have 3 people as one item. Maybe I should write that down again here. We're treating that as one thing, and then of course we ask ourselves, that gives us 7 more spaces because we have to have 10 people in total. So 1, 2, 3, 4, 5, 6, 7. So of course this is very similar to what I did up here, except it's a little more efficient because we don't have to spend all our time drawing spaces and lines and cycling things through. We can just say, you know what, treating the 3 girls as one item. So we now have 7 people and 1 item, which of course is a total of 8 things. 8 purple spaces here, and the total number of ways we can arrange those. 8 spaces is of course 8 factorial, and again, don't forget to cycle through the A, B, and C as well, which of course, how many ways can we arrange A, B, and C if they all were in the far, far left, I guess, of this photograph? And of course, that's 3 factorial, or 6. And if A, B, C was in the second position here with one person to their left, and of course, the similarity in the above diagram is probably starting to register now. Don't forget to cycle that through with the additional 3 factorial. So 8 factorial multiplied by 3 factorial, which of course is just 6, but we'll just kind of mindlessly type it in here and hope to see the same answer twice. And of course we do. 241,920. Okay, so after 2 examples, hopefully you're getting a little bit more comfortable with this trick, which is treating the group that you're trying to keep together as one item, and then cycling that one item through with the remaining people. But don't forget the additional, in this case 3 factorial, that was required here, because of course there's 6 ways we can arrange the 3 girls every time they're in one of these spaces.